Oopsie. We are now recording. Want to give a brief shout out to our friends at Cyber Florida, and we're going to continue talking about them throughout the rest of the semester at the very minimum. They've got a great podcast that I just found out about that I think everyone might really be interested in. I'm sure that everyone's probably heard about Darknet Diaries. I think we've talked about it a little bit in the past. This takes a little bit of a different spin on trying to present people that like work in cybersecurity. This talks more about their personalities, the path they've taken to reach their career, really solid stuff that like we think that you guys might be interested in. To highlight a couple of the individuals they've had on their show, they had Rachel Toback, the CEO of Social Proof Security, Women in Security and Privacy chair on their board of directors, DEF CON SE CTF champion. I'm sure that you've heard a story about her at least once in the past. She did a fantastic job, like great work. I think they might have that one recorded. So if you can find that like on YouTube, you should definitely like watch that SE challenge. I think it was in like 2017 at DEF CON, but really cool. Roger Grimes, the data-driven defense evangelist at KnowBe4, who's a security awareness educator. I know that he's like really prominent in the industry, has a lot of like really great things to talk about security awareness, and we covered that in a little bit of detail in the last semester and a bit at the beginning of this semester, but really great stuff. Also Shane Young, who is the lead technical security consultant at Rapid7, who's an on-site penetration test specialist. Personally, like those are my favorite stories when you hear about like the people that like do the pen tests like on site, like the physical stuff, trying to like do the con game of like convincing people that they are where there's like they are who they are not, and being able to get into like places like bank vaults, like seat like executive sections of like buildings, things like that. Just the ingenuity, the way that like these people go about like thinking how to get through this stuff, just it fascinates me. But they've got a lot more content out there. You should definitely check them out. And I think that they did tell me that they're also going to be doing season 3 soon. So new fresh content coming on the way. So definitely check them out. Right, so now we got some current events. Oh, okay, I guess we're going to go back to current events. Okay. Going a little bit off script here, I guess, to the Cyberforce competition 2021 virtual. Tom, do you want to get up and talk about this? Or
Nate Evans should be joining us on Zoom.
Got you. Oh, perfect. Okay, awesome. Sorry, Nate. I didn't quite get that message, so I'm going to make sure that you can be heard. Can you go ahead and test your audio real quick?
Yep. Hello. Can you hear me?
Just one moment, please.
Can you hear me? Yes, no, maybe so. Talking? No luck? In Zoom, they can hear me.
All right, Nate, can you try again, maybe?
Hello, I'm talking again.
Make sure your mouth looks correct. Speaker. All right, Nate, can you try again for me?
Yep. Can you hear me?
There we go. Yeah. Sorry. Technical difficulty.
Oh.
There you go. Go ahead and lead us through it. Let me kind of bring you up here so we can see you.
Sure, I'm glad to be here. And if you guys don't know me, my name's Nate Evans. I'm the cybersecurity program lead at Argonne National Laboratory, as well as one of the visionaries behind the Department of Energy Cyberforce competition, which you guys have participated in for the past few years. The one we ran this fall was virtual, just because of how the world was set up, and we hope to move back to an in-person or a hybrid sort of approach this fall. Next slide, please. The one this fall was attended by 120 universities and colleges from across 33 states. It included 718 college students participating, as well as 986 volunteers. 274 of those were red team members trying to hack into the students' systems that they were protecting. And next slide, please. We're happy to announce the winners of that was the team here out of University of Central Florida, which included the faculty advisor, Dr. Nederoos, Aidan Durand, Caitlin Whitehead, team captain Jeffrey DeVincent, Christopher Fisher, Cameron Whitehead, and Matthew McKeever. So congrats to all of you and your team, and we look forward to seeing you guys at the event again next year.
Yeah,
I think there's a trophy there, if I remember right. But
yep, we're holding it up in front of our audience.
perfect. Congrats to everybody, and we love your guys' participation, and sorry I couldn't be there in person.
It's all good. Thank you, Nate, for announcing winners for us. We appreciate you being here.
Thank you.
See if I can cover it. All right, so now we'll do current events. Joshua, and take it away, man.
Hello, everyone. All right, first current event. So people have found exploits in a PHP plugin from WordPress called PHP Everywhere. These have contained this plugin specifically contained bugs that people were able to exploit, and they were able to like take control and like execute code and basically take over the website. These bugs specifically are CVE 2022-24663, CVE 2022-24664, and CVE 2022-24665. The worst one, or well, the most dangerous one was the 663 because it allowed people to execute short codes on the website and again take control of the website. WordPress, I'm sorry, WordFence has offered firewall rules for its premium members, and like for just general users, they have offered like a response service to help with the exploits. The second event is Linux has been a victim of ransomware. Cyber criminals have been increasing attacks against the Linux servers and cloud infrastructures of some companies because these companies have not configured their servers correctly. And they've been able to host ransomware campaigns and cryptojacking, which is just basically stealing processing power to mine cryptocurrency. And it doesn't take up too much power to like be noticeable. So it can go undetected. These attacks are like relatively unsophisticated and they just look for general vulnerabilities because of the poor configuration of these servers. And yeah, researchers currently just enforce like you just follow the basics, just do like the basic things to just harden your server. And last one, Lazarus has put a phishing campaign against Lockheed Martin because through like job applicants. They sent out emails with malicious macros that just stole like information. We're able to do like hijack control flow and schedule tasks for like continued persistence. They've also used living off the land binaries or lol bins, but when people like researchers tested this, they found that it just produced an error. So they don't know exactly what it's being used for. And Lockheed Martin has stated that they do have policies and processes to mitigate cyber threats. And yeah, that's all.
All right, I'm going to jump through these slides because you might have seen them before. All right, now I'd like to welcome John Lundstrom. If you're in the audience, to go ahead and unmute yourself. It's a highlight of our Where Are They Now segment.
Sure.
All right, John. Yep, we can see you and we can hear you.
Awesome. Great. Hey, name's John. Was alum almost 5 years ago now. Was involved with ops, some of the CCDC stuff, competitions. Yeah. Been over at AWS for the last, essentially the last 5 years. Been doing a lot of miscellaneous stuff, working on getting third-party software to do what I wanted to do, in short. So a lot of random reverse engineering, piecing together docs. It's kind of like a CTF every day, but building software around it to enable, I don't know, over 1 million users at this point. But answer any questions if anybody has any about my experiences or yeah.
Right. So Bachelor of Science in Computer Engineering. So we don't actually have like a lot of CPE majors like that roll through. Typically, it's always like CS and IT that tend to make up like the bulwark of the membership. So from a computer engineering background as a student, like what was your focus that like brought you to Hack UCF, and like do you think that you were able to like satisfy your curiosity from a CPE background?
Oh, interesting. So before I came to UCF, I was actually I was doing IT work, and I was already doing some software development work before graduating. So I decided to originally do electrical engineering and then move over to computer engineering after a bit. So it was more of a passion project than anything. So I found Hack UCF because I was originally going to do a foreign exchange program, go over to Sweden, and met with one of the early members, Kevin DiClemente, might be a name that some people remember, or Cody, one of the early presidents. And they said, hey, like you should come to one of our Hack UCF meetings. Showed up, and I'm just like, you're talking about local privilege escalation. I kind of understand what's going on here. So started showing up to some trainings. It's just like, yeah, a lot of this overlaps with work that I've already had before, kind of done on the side. So yeah, but like there's some interesting things here that I haven't seen before. So decided to stick around. Actually started off rebuilding the ESXi infrastructure. I think in the second meeting I saw that I was given credentials, the server, and told, yeah, we want ESXi on here and vCenter. Here's a license. Have fun. So yeah, I mean, I've enjoyed my time that I had at a part of Hack UCF. The computer engineering or computer engineering. There's a lot of fun stuff with firmware that actually kind of became useful for some of the reverse engineering challenges. So like I primarily focused on blue teaming, but I did my fair share of red teaming, a couple CTFs, and actually went out to, I did Cyber Seed, and I'm trying to remember the other one, Seesaw. I did Seesaw 1 year out in New York.
Awesome. Yeah, what's up?
What was the weirdest because I've seen you did home labbing. What was the weirdest thing that you've encountered on your home lab environment?
So John, if you didn't hear the question, it's you see that you do home labbing. What was the weirdest thing that you encountered in home labbing?
There's a lot of Linux flavors, and there's a lot of software that says that they work on everything, but they don't. And so like, but is that the weirdest? I mean, so I spent a lot of time messing around with experimental things. So if anybody's run Linux servers, I'm sure you've heard of ButterFS. ButterFS has a couple experimental features around raids, specifically RAID 5 and 6 that people should stay away from like it's a plague. And I run that fairly regularly for a lot of things. And I've had some interesting things from that where I've had just complete failures, which I guess are kind of expected when it's experimental. But weird. Oh, yeah, so I run my own networking infrastructure, and in Seattle, CenturyLink is one of the gigabit full symmetric network providers. And they do a bunch of weird stuff with packet encapsulation. So you have to have unusual MTUs, which can have some unexpected consequences. So when I went through and enabled IPv6, or wanted to get that configured, I had a lot of weird behaviors where sometimes things would work and sometimes it wouldn't. And that ended up boiling down to MTU and TCP MSS settings essentially not being set correctly. But like finding that required essentially setting up tap interfaces on my switch and essentially just seeing them getting fragment responses, since the network equipment or the firewall was just eating the responses.
So John, in that specific situation, is it the extra large packets that were getting screened without like any kind of error reporting or logging or anything?
Yeah, so what's not uncommon with like network infrastructure is that as you send packets, that each part can specify the maximum segment size that's allowed for a TCP packet. And for some reason, CenturyLink infrastructure doesn't do it. They'll do it on their outer layer, but they won't do it on the inner traffic that actually needs it applied. So the behavior was essentially like what was it? It was, yeah, I would essentially get like invalid packet responses. And IPv4 traffic worked fine. It wasn't until I tried to do something with IPv6 where it really broke. And I think a lot of that has to do with its reliance on ICMP for a lot of the, oh gosh, what is it called? Essentially configuring like route tables and things. So I was missing settings, and it was notoriously bad on my phone. Like most of the servers would actually handle it okay. Like once they see that large packets don't work, like they kind of auto negotiate down, but Android, for example, does not. And IPv6 is still very fragmented when it comes to client configuration. It's getting better, but it's still a mess.
I think that's all the questions we've got time for, but if you want to just go ahead and take the last little bit here, if there's any project that you're like currently working on or group that you want to broadcast or like, elevate up a little bit, you want to like let people know about, go ahead, let us know.
Sure. So I'm going to DEF CON this year. So if anybody's interested to meet up with some of the old hacker fam, I would say it's definitely a fantastic opportunity. It's a lot of interesting talks. And if anybody's interested in low-level networking equipment or reverse proxies and is looking for either an internship or a job, hit me up. I'm always looking for people who are interested in that type of stuff.
Awesome. Well, thank you so much, John. We really appreciate you coming out, making time for us. And anyone that wants to talk about that stuff, I'll send them your way.
All right. Thank you so much. And I'm also on the Discord with Jay Lundstrom. So.
Thank you, John. Look at that. Got an audience even outside the room, guys. All right. So now we're going to welcome Addison up for Proxmox.
All right. So Proxmox or Proxmox virtual environment is a hypervisor that you might run in a server or home lab. You can run it you can either do Lexi containers or full VMs. You can theoretically cluster an unlimited number of nodes. Probably not a good idea. Has very useful monitoring features for all your VMs and containers you might be running. Also, there's no limit on the number of VMs or containers you can run until you break your hardware. So we'll demonstrate a couple of the useful features of Proxmox. Let's see here. Share my screen. Okay. Everyone can see it. So this is Proxmox. You can see one of my nodes here. I've titled it PVE ASUS because it runs as host of ASUS. It has uptime of 91 days, doing pretty good there. I'm not using very much of this node. You can see all the usage of everything. The useful charts. We can go over here. You can see there's only one container on this node, which is my unified controller. All I've got running here. You can do a bunch of very interesting stuff. But we can go ahead and create a brand new container. And we're going to call this container test container. And then we're going to yes, we're going to get SSH key in here. So I don't have to type password. As for the template for containers, you don't have to have VM and come set up. I have Debian or Ubuntu. I'm going to use Ubuntu because I like it better. Disk 8 gigabytes, that sounds fine.
Actually, we got a question.
Yes.
You said that this node wasn't really being used. At the moment, what are these nodes normally used?
So this is just running my home lab at home. You can install whatever you want on there. You can have servers of any kind. You can put a Minecraft server, email server. I have unified control. You can put logging server, whatever you want. It should match the hardware. So you don't want to put something that uses so much. This is like an old laptop I had, so it's not going to do much. But you can put anything you want on here, realistically. CPU cores, we don't need one. Memory, everything here seems fine. We're going to let it be DHCP because that works. And then we will start our new container. And then it will think about it for a second. And then container 100 will exist. All right. So now we have container 100 over here, just slowly starting up. You see in the console, you can view a web console of your VMs. Nope. Like you can't. Still creating apparently. All right, well, it takes a little bit longer. Oh, there it goes. Now it's created. There we go. It's too impatient. All right, now we can connect to our, you can just see the container is going to start up and it will do all of its stuff. Oh, I don't have a password for it because I never set up a password. So yeah, I guess I can't log in, so I didn't set a password up. Oh, well. But we can see this container is now using 7% of its 500 megabytes of RAM and nothing else. We can also look at some clustering features. So you can see I have a cluster, it's core rated, it's happy. I've got, so on here, 6 VMs and 4 containers. You can see some average usage of my cluster, 6% of my CPUs, 34% of my memory, 17% storage. Anyone have any questions? Yes.
Why is everything in biggies instead of the little bytes instead of big bytes?
I don't know. I didn't develop the software. Also, I've never noticed that either. Yes.
So, does it support Cloud Init?
It does support Cloud Init. That is what it uses for the containers. All right. Give the sharing back to Daniel.
Sure. Thank you, Hassan. So now we're going to go through our NCAE CyberGames, the sandbox. We've got Pac-Man Ping, Mayhex, World of Bills, and Capture the Flag. So now, am I saying that right? Yes. Sorry. Okay. Go ahead and come up. Show us Pac-Man Ping.
Right, everyone. So we are playing with packets. So we are using Proxmox interface. So we can just log in there. We have to create and launch the environment to be able to go to our sandbox challenges. So, and the default password, as we can see, is password. We can connect the challenge. We can go to the website and it will open up the Ubuntu login screen, and we can enter the password there. As we are navigating through Ubuntu, you will notice that we are not connected. The wired network is connected, but we are not connected to internet. It does also have games attached to the sandbox, which gives you pretty much idea. It's more so visual. So it tells you that you've got
your Ubuntu and there is a router. It's connected, but it doesn't have IP. So, and there's no network traffic following through. And it tells you that you want to connect to static IP, which they provide, and they want to do the number 7. So they provide that information there, the static IP that we have, and we can, go ahead and set up that static IP. Now, I'm pretty sure everybody has set it up static IPs. So it's fairly easy. I mean, you can go to settings and go to network settings. And if it's wired network, you can just go ahead and change that there as from DHCP to static. That wouldn't be easy. So we can do that, but we are in a challenge. So we have to learn something new. We can not do that via GUI. Good. So we can do it by command line interface. We have the commands here. This is the game I was talking about. It tells you that, this is the IP address we want to set to static, and we can set that up. This is the way to set up the static IP. Now, as we can see, the first command, IP link, there's no IP attached to it at that moment. And we can go to our etc netplan directory, and we can see our YML settings there, and we can go ahead and edit that. Now, this is the command. Since it is into etc directory, we do have to do sudo, and we can go ahead and edit it. So this is how it looks like when we open it in Nano. It just initially had the network to render and Ethernet, but we go ahead and add the information. We don't want to do DHCP automatic, so we can go ahead and set that up static. This is the IP address we want to set it to, as it was given to us by the game. And once we set it up, we should have internet and we should have traffic falling through our machine. Now, that was the first part of the challenge. And there are other parts of the challenge. We can all do that together. I haven't really had a chance to go through all of them, but I did start this third. I think I finished the third one. And there are some interesting stuff. We are going to look into some web servers and SSH and a bunch of things, but I'll leave that up to all of us so we can figure that out. All right, we have Finny hacks.
All right, so I'm going to go over mini hacks today. We're not going to be able to get into everything, but basically, this is what we're working with right here, right? The framework in Proxmox is going to give us 4 different boxes, and they essentially all exist. We have to get them to talk to each other, essentially trying to get a web server like speaking to the scoring server. I'm actually going to do this live. We're all going to try to participate. So if you've done like routing before, if you set up boxes before, cool, help us out. If you haven't, great, you're going to learn. However, got to go over a couple things. We're not going full depth, right? I'm probably not even going to get to the end of the challenge. We're shooting for about 15 minutes of like content here. So if this is something that like you're interested in, we can go more in depth later on. What we will be covering is how to find an answer. If you don't know how to do something, there's an entire internet of resources, but I'm going to show you how you go about finding that answer. How we're going to navigate the environment inside the NCAE CyberGames, as well as we're going to introduce some virtual networking concepts, what it means, why boxes might not be able to talk to each other, and how you might not want them to talk to each other. We're also going to explain how to achieve success in this competition using this specific challenge. This will be something that recurs throughout all of the other challenges. As you well know, if you've tried them yet so far, it's a lot of repetition, it's a lot of information that gets passed from one challenge to the next. So, but that's it. Let's do this. So I'm just gonna open up another tab. I'm gonna go to NCAE CyberGames. Boom. We're gonna hope that it loads quickly. All right. We'll log in. I did not make a sacrifice to the demo gods, so we're kind of praying here. Because MFA is the thing. Don't steal my code, please. Oh, okay, that's a lie. Well, okay, you can steal that one. Can't steal this one. Hey, there we go. Awesome. All right, so first things first, once you log in, you hit the splash screen, right? So it's a brief discussion about the competitions. We're gonna go to sandbox, just by clicking, not the drop down. So we got Pac-Man ping, mini hacks, we've got world bills, capture the flag. You can watch videos about them that goes over like what exactly it is that you're doing. It gives a nice high level overview and introduces some concepts, things that you should be familiar with. In mini hacks, I've already got an environment existing. I haven't done anything to it. I just want to make sure that it was good to go. We didn't have problems. If you do click how to play, it's just see here. There's one that I wanted to do tutorial videos. So this is kind of important. What NCAE has done is they've gone through and they've given you a whole bunch of tutorials on more or less every skill set that you're going to need to be able to complete the sandbox, as well as the majority of the rest of the challenges. They're broken down into tutorials by topic area. So Linux administration, introduction to networking, routing and services. You should be able to do all of the challenges using these, but I'm not going to reference these directly. These are great. It's just, it's going to take up a bunch of time. And also, you're not always going to have these available for you when it is that you're doing this in the real world, or if you are doing a different challenge that might not have this information available to you. So we're going to go and we're going to open up the mini hacks environment. Cool. Log in, redirect. There we go. All right, cool. So this is Proxmox. We were just speaking about it. This is how you manage your VMs. This is how you like make sure that everything's like going well. You've got two sandboxes over here. Sandbox 2 is not for you. Sandbox 1 is for us. So we are going to go over here and then we're going to expand this. You're going to see that we've got a Kali external, CentOS, CentOS router, Ubuntu desktop, and Kali internet. We're going to start with Kali external. Double click it. It's going to load a. It's going to want to load. There we go. All right, so this is a VM. I'm gonna just kind of put that right there. All right, your password is gonna be password. Super secure.
Very secure.
Very secure. Boom. Okay, cool. So this is the image you saw earlier. Basically, what this is saying is this is the. All right, so what it says, we need to configure our team infrastructure to follow the topology shown and to successfully route web traffic from an external network through a router to an internal web server. The number is the team number, right? So this is automatically generated every single time that you launch this environment. It will give you a new number. So you have to do this, well, preferably manually. You should be able to do this manually. We're going to go to the. So 172.20.0.1 in a browser is like this right here, shows you the dashboard, all the other like scoring stuff. We're going to go here, show you the scoreboard. VMs are great. There we go, cool. All right, so what you can see is in the sandbox, we've got a router, a web port, and web content. Like right now, it's flashing red. What does that mean? It means it's down, no response. When it's up and running, it essentially, so much lag. What basically is happening here is the scoring server is trying to get in contact with all 4 of these boxes, right? But it doesn't have a route to them yet. Once you establish a route by defining a static IP, it will be able to contact the scoring server, and then the scoring server will denote that it has connection with that box, and it will bring it up. When you get it all up and it's fully functioning, you will complete the round and it will award you. And in addition, we also have some challenges, crypto, reversing, and trivia. I'm not going to get into these, but they are here. You should check them out. It's pretty cool. But I'm going to go ahead and, so I'm in my Calibox, right? So the first thing we need to do is we need to get this on the network. Does anyone know how to figure out what your IP address is from the command line? Can anyone tell me the command for that? What's up? I have config. That's a great one. Does anyone know another one? What's up?
IP space ADDR.
IP space ADDR. That's a great one.
Seems like 3 extra characters, just IP space A.
IP space A.
Hostname tag
Hostname tag I. Anyone else? Okay, so as we see, there's a bunch of different ways to get the same thing accomplished. And just like this challenge, I'm going to solve it in a way that makes sense to me. That doesn't necessarily mean it's going to be that way for you. Find what works for you and do it that way. Don't try to just do it the way that like everyone is telling you must be done, unless there's this like a reason that you have to do it that way. Be curious. So I like IPA because it's a lot less typing and, well, that's just IP. Oh, okay, well, a lot of spaces. Yeah. So one thing that you'll note is because we're launching a VM in a web browser and we're doing everything over HTTPS, it is a little bit slower, right? And because of that inherent slowness on every single connection, it is going to lag out a little bit. That means that I'm going to have some commands that are, I'm just gonna have to completely backspace because it's gonna have a million forward slashes for whatever reason. But looking at this right here, we can see we've got loopback, and then we've got Ethernet 0. Right here, we've got 172.20.0.2, right? Let's remember that real quick, and let's go back and look at our diagram and see what it's supposed to be. There we go. All right, drag this down all the way. There we go. All right, cool. So this is the external Calibox, external production. It says it's 172.20.some number and .100/16. That /16, if you don't do networking, is important, and we're going to cover that in a little bit. So my team number is 98, which means that this box's IP address is supposed to be 172.20.98.100. I didn't say the wrong number there. Yeah, okay, cool. So what we're going to do. Does anyone know how you define a static IP address inside a Calibox in like 1 or 2 commands? Cool. So if you don't know, it's actually in etsy/networks. So I'm going to just show you that real quick. ls tag LA is list, and then it's going to give you a bunch more information. I like this because usually you want to find hidden folders and you want to know like who has what like permissions and everything. So ls.la is what I always do. Then we're going to go /etsy/
This might be a bit late, but Zoom can't see that window.
Oh, really? Well then, that makes sense. I'm so sorry, Zoom. Thank you for calling me out. Let's get a new share. Okay. Hey, Zoom. Can you see me now?
Yeah.
All right. I apologize. I hope you didn't get too lost on that. Okay. ls tag LA. Oh my God. LA space. Okay, /Etsy / come on. Tab complete for the win. Come on. Oh no. Okay, hey, there we go. So we're gonna go network slash, boom. All right, what that does is it lists what's in that directory, right? We can see that we've got a couple of .ds, right? We've got a file that is interfaces, right? So what we're gonna do is we're just gonna like take a look real quick and see like what interfaces is to make sure that that's exactly like what it is that we're looking for. So I'm gonna tap up, right? That's gonna bring up the last command. I'm gonna scroll all the way to the side here. And I'm gonna very carefully delete. And we're gonna say, oh my. Slash Etsy slash network. No. Thank you, WPA2. You're such a winner.
Everyone's favorite Wi-Fi network.
Right? Here we go. Okay, cool. So what you see right here, hopefully, can everyone see that? Is that good? Does it make sense? What you're seeing right here, right, is all of the information that's inside that file, right? So pounds denote or hashtag denotes comment, right? So comments line, comments line, source, loopback network interface, auto LO, iFace LO, blah, blah, blah. What we want to do here is we see auto Ethernet, iFace Ethernet, iNet static, address, net mask, right? And we see right there, that is the same address that we revealed earlier when we did IPA. So what we're gonna do is we're gonna like edit that real quick. And thankfully for us, Ali doesn't require us to use vi or vim, which is awful. And anyone that disagrees is not a real hacker.
So do I.
I'm kidding. Also, you shouldn't do what I'm doing right now ever. But because we're having problems with like typing things and like getting the weird like output, I just did a command called sudo su, and what that does is it elevates me to super user and retains that, which means that even if I close, well, as long as I don't close this session down, all of my commands are now run at root, right? The reason that you don't do this normally is because you don't want to leave an open root session around for someone else to come in and then do whatever they want to do. Jeffrey, I understand.
Why didn't you use something like sudo -s?
That's a great question because I'm not really familiar with that command.
Yeah.
Do you want
to? It was like one actually elevates you to super user versus using sudo or something. So.
Okay. So I am now root. As you can see, it's that little death's head there telling us that it's a bad idea to be doing what I'm doing. But we're just gonna press. We're gonna do nano, and then we're gonna do Etsy slash network slash interfaces. Cool. So now I'm in a text editor, right? And I'm just going to come over here and I'm going to set my IP address to what it's supposed to be. I'm going to move this real quick so you can see the team number. And so my team number and what my address is supposed to be. So we are going to do a couple of backspaces, hopefully only a couple. Right. So 172.20.98.100, right? And net mask is this number, right? So down here, you'll see 172.20.98.100/16. Does anyone know what that /16 means? Does anyone want to answer what that /16 means for a prize? Okay, I think I saw, I haven't heard from you. You in the back, yeah. That's correct, it is a subnet mask. Go ahead and come up here and grab a prize if you want. Yeah, so you'll see a bunch of slashes that appear at the IP addresses. They cover the subnet mask, right? So you'll see like often in this specific one, yep, whichever one you want.
You might have to open the notebook if you want that.
Oh, this.
Yeah, you don't get all of them, just one of them. But if you want one of them, you can upload that. All right, there you go. Cool. So we got /16s and /24s. Can anyone tell me what 255.255.0.0 is in slash notation? Yeah, what's up? /16, you're right. Go ahead and come up here and grab a prize. So as we can see here, 172.20.98.100/16 should translate to that same IP address on a net mask of 225.225.0.0, right? What's up?
Do you know why it's -16?
So yes, but going into subnet mask mathematics and like how it is that that's determined is kind of a whole topic on itself. And there are people in this room that are way more knowledgeable about me that will probably give a much better, more succinct explanation. So if you want an answer to that, let me know, and I'll point you in the direction of someone that can give you the best answer for that.
Sort of binary number.
So, so we've got that edited. This is good. So what we're going to do is we're going to hit Control X, right? It's going to ask us if it wants to save the modified buffer because this is nano. We're going to say yes. And then it says file name's right. We're just going to overwrite it. Boom, there it goes. Now that should mean that my machine can now talk to the scoreboard, right? Scoring server. And there's a really quick, easy way that we can make sure that that happens without having to do any kind of like other strange, crazy like tools. Does anyone know the easiest way to check connection to another box on a network? So, yeah, you can ping it. Well, hopefully you can ping it. So we're going to do ping, no, not ping, ping 172.20.0.1. We're going to see if we can get some. Hey, look at that. So what it's doing right now is it's sending 64 bytes across the network to hit it and then return if it's successful. We're going to hit Control Z, and then I'm going to exit this. Right. And as you notice, it changed the, so this is, this terminal that I'm in right now is running ZSH. When we get into the 1.2 box, if we're lucky enough to get that far, you'll notice that it is not this, it will be bash. ZSH is just a different type of shell. So in the shell, we changed from root back to sandbox. So now I have de-escalated my privileges. And now I will have to re-elevate if I want to do anything at the super user level again. But let's just double check our scoreboard and make sure that it's updated. Well, our router is not online yet. Our web port is not open yet. Our web content is not correct, but we do know that we can ping the scoreboard. So at least we've got one box good. So I'm going to go ahead and minimize this, and let's get the, well, actually, no, because I need to expand that one last little bit. We're going to go back to the dashboard, and we're going to cover what this topography means, right? Does anyone in the room not know what this topography map means? Couple people? You don't have to be actual, it's fine. I didn't know this until like last year. Yeah, cool, awesome. So what this means is you've got a scoring server, all right, and everything that's connected by a white line can talk or should be able to, right? Like by the diagram that it shows, right? So we've got this external Calibox, it's a box. We've got this team router, which is shown using like a different symbol, right? The router itself is going to take packets from this external network and is going to translate them to talk to these boxes down here. That's probably not exactly the best explanation of what it's doing, but it's a short explanation of what it's doing. So these, if you can see, have 192.168 prefixes, and these have 172.20 prefixes, right? These are two different networks. This router is just allowing that information through. Well, it is also changing the subnet mask, but it is also a completely different IP address like notation, right? Well, I'm not the greatest person to explain networking concepts, but I'm trying to hit this at a high level. So what we're going to do next is we're going to jump in this router and we're going to configure this so that it's able to talk to the scoring server and then send any packets from the scoring server down to these boxes down here. That's up. Exactly that, yeah. So if this were your home network, right, this scoring server would be like your internet service provider, right? This would be another box that's on like that network. This router would be the one that like they issue to you that you connect to so that you can get internet. And then these two boxes down here would be like your home networking devices, right? That would be like a like your Calibox at home in your like your home lab. And then this might be like a like any kind of server that you've got hosted there as well. So we're going to try to hit the router while I still have the opportunity. Jeffrey, just go ahead and stop me whenever we've gone too far. I don't want to take up all the time for the meeting. Okay, cool. All right, so
Like 5 minutes left.
okay, awesome. So we're probably going to get to CentOS. All right, so as everyone can tell, we don't have a graphical user interface here, right? This is just a server, right? So what we're gonna be doing is everything from the command line, all of the different things that I had to navigate through before, I'm not gonna have access to those now, right? So this is where things get a little bit more in depth. If you aren't familiar with the command line, you're not really like got a lot of experience using it. Working in boxes like this is a great way to kind of like to stretch that skill and like get more comfortable with it. So we're gonna go ahead and log in and hopefully not have problems. Oh, we're gonna have problems. Hey, I got it. Okay, awesome. So we got username and password. If you didn't notice, the cursor wasn't moving for a password. It doesn't do that for Linux. So right now we're sitting here. Let's see what we got to work with. LS, please. All right, nothing. Right. That's weird. Let's make sure it's nothing. LA. All right, so nothing. What you see here, the dot bash history, logout profile, bash RZ, all that stuff is just hidden files that exist in the directory that we're in right now. I'm not going to like try to jump all over this box because what we need to do is we need to get networking up. So I'm going to NM2E, I think is the correct. There we go. All right, so network manager, something user interface. Terminal user interface. Thank you. Like I said, not the most knowledgeable about this subject. So we've got a couple of options here. We can edit a connection, activate a connection, and we can set some host name. Right now, I'm concerned about editing some connections. So I've got ETH1 and ETH0. So I'm going to pull this box up beside my other box so that I can actually look at what I'm supposed to be doing because my memory is not the greatest and I sometimes forget numbers. So what we're going to do here is we're going to go to edit ETH0, and for like brevity's sake, we're just going to call this external, right? That way I can just determine like what network that is. Move, enter, there we go. Okay, and we're going to go to IP4 configuration. We're going to set IP4 configuration to manual. We're going to set IPv6 configuration to ignore because no one likes it. Come on, you do it. There we go. All right, cool. So now we're gonna add an address if it wants to. Okay. Hold on. Address. Can anyone tell me what the address is supposed to be for the external network? Yeah, what's up? Yeah, 98, but yeah, you got it. That's right. So it's 172.20.98.1. All right, and as we discussed earlier, we slash add gateways. Gateway. It's manual data server. So that wait slash right that was slash, please be a slash. No, that was a slash 16. Okay, thank you. All right, and then we're going to go to come on. Here we go. Okay, all right, so we got external, and now let's go ahead and edit ETH1. We're going to call this internal. Eventually we will. Cool. Okay, we're going to leave this automatic for now. I get down here. I have another question. Or there we go. Okay, so I skipped over it last time, but we're going to dig into it now. So I've got a couple options here, right? I can disable IPv4. I can set it to automatic, link local, manual, or shared. Does anyone know why it is that I might want to choose manual for this? I think I saw your hand go up first. Yeah. That's right. As we will see, well, we probably won't have time for it, but later on, we'll be setting up automatic IP address determination. But right now, because this router is doing its thing, we're gonna set this to manual. Hopefully, there we go. All right, we're gonna add an address. And can anyone tell me what the address is for the internal network? Yeah. 192.168.98.1/24. That's correct. Does anyone know why it needs to be /24? Sorry, I was not looking. Jeffrey.
Because you are doing everything from 192.168 hash 2 to 254. So you want to make sure you get the entire range properly.
There you go. And I might be incorrect in saying this. Please, someone who knows more about networking, correct me if I'm wrong here. But as you continue to use up sections of a domain, you need to continue subdividing your subnet mask because you don't have access to the entire range every single time you define a new subnet, right? Do whatever I want. Oh, okay. There we go. Come on. All the way. There we go. Okay, here we go. And we're going to go back. So now we've defined the networking, we need to activate these connections. So we're going to activate external, we're going to activate internal. We go back, and then we are going to quit. All right, I'm going to hit clear, all that blue. All right, so then now we should be able to ping the scoring server, just like we did last time with external Cali. So we're going to do not 172.20.0.1. And look at that, we got that, cool. But just because we can reach out to it doesn't necessarily mean that we verify the connection. So let's go ahead and double check our work just to make sure. We're gonna go in here and we're gonna say, let's ping, not ping 172.20.98.1. And there we go. We also have packets coming back there. So what have we accomplished so far? Can anyone give me a short recap on what it is that we've done? That's right. So on our external network, our 172.20 network, we have now set up networking between two components that can connect to a pre-existing scoring server. And that means now that the scoring server should be able to detect what the router is up, and it should list it as such. So let's double check that. And look at that. The router is now up. Cool. Jeffrey, is that all the time that I've got?
Yes.
Okay, awesome. So this is where we stop. But if you want to continue learning about more of this stuff, you want to do this challenge on your own, it's super, super easy to reboot this when I'm not trying to record a Zoom session and broadcast at the same time. I promise the performance is just a little bit better when you're using your own machine. So thank you very much. And I'm going to shut down my stuff. And we want to welcome Jeffrey to the stage. He's going to talk us through the next bit. There you go. Thank you so much.
So today we're going to be talking about the World of Bills challenge, which we've seen some of these skills before with Daniel, but we're going to be more so doubling down on CentOS and the use of Bash. So first, let's introduce some lore. So the lore of this challenge is that you've been contracted by James Rice Incorporated, a company that for some reason is only hiring people named Bill. No other names. You have only Bills. So the catch though, all these Bills at James Rice Incorporated are incompetent and you have to fix their mess ups. So first we need to get started. So we have kind of these 4 easy steps to get into the environment. First, you are going to be logging into the Proxmox or the sandbox environment, which will eventually take you to Proxmox. There is a button, and I'll show you it, that says Start Environment on the NCAE CyberGames sandbox page. Do not try to start the VM through Proxmox directly. You're going to mess up some auto deploy stuff. Second, you're going to be accessing your actual machine you'll be doing everything in. This is nicknamed the build client and is accessible via Proxmox's no VNC interface. If you really like the laggy interface you just saw, well, don't worry, we got more of it. Third is you're going to have to wait maybe a minute or two and then type in ls, which will show that a file has appeared named cyber user and then 2 numbers that are randomly generated. And if you cat that file, you'll also be given the name of the bill you're taking over for. Note this combination, they're effectively like a username and password pair. And then finally, we're going to connect to the challenge website and follow the instructions almost blindly. So a few things to note. One, I hope you do not like Nano and love VI because there are no other text editors in this environment, just Vi. So I hope you know how to use it. If not, it's not that bad, and we'll be briefly going over the basics that you need to know. Second, you have to use that no VNC interface. There's no SSH. There's nothing else. You have to use the web terminal. Third, you cannot transfer any files. So there's no copy paste functionality or an internet connection or really anything other than standard in and standard out. So you're going to have to rely on that. If you really need to paste large blocks of text, probably have a script do it for you. And fourth, work smart, not hard. So this is a kind of a dummy environment, and there's a lot of wrestling you have to do with that web interface. So there are a few tricks that you can do along the way to kind of help you out. One of them, you can set an alias for the IP in your etc host file. This effectively is saying, hey, this is a shortcut to access the IP address, kind of like DNS, but not. Do not do this in a production environment. I'm only doing this because it's going to be a demo and it'll help us work faster. Second, a lot of the links you're going to see have /index.php at the end of them. This is, in most web servers, completely optional. So we can actually just drop this and save typing in like 8 characters, which is always nice when we have to type everything every time. Or you could just do the up arrow. So I'm going to go over the basic setup and challenges 1 and 2, and leave everything else as an exercise to the viewer. So I'm going to share my screen. Okay, can everyone see? Alrighty, thank you. So when you go on the NCAE CyberGames site and click Sandbox, on top of Packetman Ping, you can go down to World of Bills. So this environment started, you would have something that's create environment. So you click that button, and then after a while, you'll get this interface, but pause will be substituted with start. You click the start button, and then you wait a second, and then if that doesn't work, try it again, and you'll eventually be able to click launch environment. So I'm going to do that quickly. And then I'm also thrown right into Proxmox. Now, I'm also going to say something very quickly about this. Sometimes the create environment button does not show up. If it doesn't, you might want to check your internet connection or maybe change browsers because it seems to be somewhat finicky. It might take a couple tries. You might have to wait an hour because it might just be down. It's an ambitious competition, so it's down for some kings to make their way up. So I'm going to be launching the build client. So I'm going to double click this, and then we can see our environment settings. So now I can go to console. And then I'm actually going to load this up, so we can actually kind of see what we're going to work with. So I know I didn't show the credentials, but if you click that how to play button, you'd actually see the credentials show up. So because of this, I know my username is Bill and my password. Anyone want to take a guess? It's password. You see, when I said these people were, I'm sorry, Brandon, it's not Bill, it's password. You see, we were kind of hinted at this because they said all the Bills were incompetent. Whoever made this challenge really does not like the name Bill. But if we use password, hacker noises were in. So as I alluded to, I'll on to Alias, and that will give us cyberuser91.txt. I'm going to cat that. If you want to know what I just did, I used a wildcard. So I pretty much cat everything in this directory. And if you see, it's actually really just the one file. So I'm not 100% total for. Oh, it's because I did LS, not that. LA. You'll see there. So now we are Bill the Cheerful. And we're also, if we quickly go back into the how to play, we're given this curl command, curl-k, and then an IP address. So I'm going to use that information to connect. But first, does anyone remember what I said earlier about Etsy hosts and how probably you shouldn't be editing that file, but we're doing a competition over a web interface, so we're going to do it anyways. So this is the part we're going to do it. Yes. This is very.
You got an editor.
I know I did. And the password. Did I type in the W in password? I swear this is faster when you're on your home network. So now it's time for the part of the meeting where I ask you all if you know how to use VI or Vim. So does anyone know, if you know anything about Vim, you know, I can't type right now. I did because I pressed the key. What key did I press? Correct. So now we have a slight of a problem. I spammed my keyboard and now there's a you. So does anyone know, and I'll be doing this one for a prize, what do you have to do to quit without saving anything? Incorrect. Victoria. Escape? Of course.
Escape is a bit upset because you have your
Escape, colon, Q, exclamation mark. Enter. Ta-da. Come up and get a prize. Or you can get a beautiful pre-meta notebook. I just have to open the pre-meta notebook. Okay, so I'm going to actually reopen. I'm going to have a few opportunities to get free shit. So now we already know you said that we click I to edit things. And I'm going to type in the IP address we were given. So let me go to the end, line. 2 characters off. Okay, so now we want the IP address, which if I'm not mistaken, is going to be, what would it be? This, 172.19.01. I'm gonna put it right there. 172.19.01, and then I'm gonna name this Bill.
You forgot one.
Think you know VNC? Very cool. So now, does anyone know the key combination? And this is also for a prize to save and quit. You in the back. colon W Q. You have to also click escape first. But that is correct. So come up and get a prize. So, okay, now I set an alias, so I can now just ping Bill. And there we go. And then I can use Control Z or Control C to terminate. So now let's actually curl Bill. Okay, so we see that the site is managed by Bill the Idiot. Enter at your own peril. So we can use curl, which is a command line utility to mess with, like send network requests to manage the site, because we don't have a desktop environment. So this is like the only way we can actually see stuff. So, and if you're thinking wget, no. So I'm going to go to the bills page. And it's going to tell us a bit more of exposition, because of course it's going to. So we know that the accuracy of information is not guaranteed. To identify which bill you're taking over for, do what we just did, and cat for cyber user, blah, blah, blah. Which we're cyber user 91. And then we're going to effectively use this as a username password pair to access the rest of the website. So I'm going to do a user and then cyber user 91 cheerful, and then Bill's bill cheerful, and we cannot forget that leading slash, but we can drop off the index.php. So now we're in the, I guess you can call it the scoreboard. We're going to do the first two challenges, but the rest are relatively similar. So the viewer instructions for each challenge, we have to go to /activity and then a number. So if we want to do activity 1, there we go. So it's saying configure IP address to be what it gives you. When finished, retest. So that's what we're going to do. So does anyone want to recall, this is not going to be for a prize, what's a good way to check what our current IP address is? You can do IPA. So we can now see in the ETH0 interface that we have a 172.19.0.191 when we want a 165.138. So effectively, we just have to change those 2 digits. But we don't have a interface. Now, I know that Daniel showed one way to do it. I'm going to go a slightly different approach based on my Google viewing. So I am going to use text editor to edit things. So I am big network scripts IPCFG and then the name of the interface. If you're asking, how do I know that? It's because I have notes in front of me. I'm not superhuman. Okay, okay, so Q. Of course. Oh. Okay, I actually have my notes wrong. So now we have to, I'm gonna do kind of what Daniel said, and it's like, how do you find the answer when you don't know? You can use Google, or in this case, DuckDuckGo. So CentOS change static IP address. Okay. So yeah, it seems like this is the same path I had. I think I just made a typo and did IP instead of if, which if we take a look is exactly what I did. Yes, this is totally Microsoft NT, as we all know. There we go. This is the text file I was looking for. So we are going to do the same thing. Click I, and then we are actually going to completely forget what the IP address is. Does anyone happen to be more observant than I and remember? That's completely okay. You remember? That is not it, but that's not a big deal because W information. Okay, I don't know why I wrote that. This is fine. Okay. And I'm going to control this 165, 138. And now we can do escape, right, quit. And now if we do that, we can see it should be our new IP address. So does anyone know what step I might have missed? Caitlin? You are about right, yes. So, but we don't have netclient. So there is a very similar command. It's etc init.d/network restart. Same concept, we are effectively restarting the network. And now if we do IPA, we get the, I believe that's the new IP. So now in this challenge, to check your work, you want to go back to your Bill's homepage, usually. $165, 138. And the reason I say usually is because it usually takes a couple of tries. But we're not going to worry about that. This is the solution. Yeah, in my experience, it just takes a while to apply. But with that out of the way, do you think we have enough time to do activity 2 or?
Already past 6:30.
Okay. Okay, so unfortunately, I do not think I'm going to have time to do activity 2, but I'm going to briefly introduce it quickly. So the goal of this is we're going to create a new account to do everything in, add it to the wheel group, which will give it pseudo permissions, and then we are going to block its way out of the shell. I'm going to do this really quickly since it should be a few lines. User add, and then cyber user 91. And then now I do sudo password cyber user. Okay, what's a horrible password I should say?
What?
Got it. That is my password.
It's a palindrome. How is it a palindrome?
One written backwards is still one.
Okay, and then what I'm going to do is I'm going to use, I know this is kind of small. I'm going to use user mod, and I'm going to just set it as it. Now it's in the group, and now I'm going to exit. Now I'm going to log in with cyber user 21, password 1. I'm in. Thank you, Addison. And now that I'm in, I should be able to use sudo. Password 1. Now this is the exe password file. So does anyone know what we are supposed to do to prevent the Bill user from logging in? If you do, I'll give you a prize. Sure. Actually, no, you already answered. Cameron?
Change is, change the /bit/bash to something else. In this case, has been no login should work.
That would be indeed correct. Yeah, the reason that we're going to do SBIN no login is because SBIN no login is used elsewhere. So now, if we now do curl k if user cyber user 91 or bill name is, I don't really care. But anyways, I'm going to show we can't log in, so the challenge is complete. So. It was a bit more rough around the edges than I'd hope, but I hope you at least kind of know where to go, even if I had to speed run the last bit. And finally, we have capture the flag. Seriously, no one wants the plushies?
Just make sure you talk about it a little bit, and then you can like you don't have to go up front. Just in case.
All right, so last category in the NCAE games is capture the flag. Basically, it's just like a run through, or it's just like a list of challenges that you just got to you can do. You do the challenge, you obtain the flag, however means possible, through coding, through brute force, through commands like they were doing through a shell. You obtain the flag, you put the flag in, and basically it tells you if it's right or it's wrong. If it's right, you get points, and those points go to your team, and you might win. How you access it basically is just to go to the website, you click sandbox, you scroll down to capture the flag, and you create the environment. Then you want to click launch environment and then start environment. And then once you get into the Proxmox server, just go to the sandbox, click that, and the credentials to log into the VM are sandbox and the password. Then you want to access the web browser, and then you go to the homepage C2 games, you log in with the same credentials, you put challenges at the top, and then you're free to click on. Yeah. Good. Yeah.
Thank you, Josh. All right, so that is all the content that we've got for you tonight. As I said before, after we wrap up the meeting, we're going to be getting together in Cyber Lab to continue going through this. And I don't know if anyone else is hungry. I definitely eat, so we might fall back for some food and then do NCAA after. Thank you all for participating, and I'm going to wrap through the last little bits we got here. If you're not a part of operations and you haven't heard of operations, guess what? That's the group that runs the club. That's where all the meetings are planned. That's how everyone gets to choose what cyber challenge we're doing this week, and what tool time's going on, and who's delivering what kind of content. If you want to help run the club, you want to be a part of this, please reach out, let us know, or just show up to the meetings. They're at 8 p.m. every Tuesday in the Cyber Lab or on Zoom at hackucf.org/opzoom. We'd love to see you there. Projects, infra, web, and design do not have anything shared this week, so I'm just going to push past that. If you're not on our mailing list, join our mailing list. If you haven't checked out our shop, why not? Buy something. If you aren't on our Discord, you should definitely join our Discord, and we do that Twitter thing too sometimes. Thank you all so much for coming. We really appreciate you. Have a great week. Have an even better weekend, and we'll catch you next time. Bye.